For this section, we're going to be talking about complex numbers. So your essential question is, what is the purpose of the imaginary number I? Well, the imaginary unit I is equal to the square root of -1. So if we think about that, we can't take the square root of a negative number. If I multiply any number by itself, it will always turn out positive. So there's no way possible to take the square root of a negative number, which is why the imaginary unit I was invented. So this makes it possible for us to take the square roots of negative numbers. So that also means that if I take I squared, then that would be like taking the square root of -1 squared. And when we square a square root, those cancel out, and so it just equals -1. So I squared is equal to -1. That will be important to remember for later. So for instance, if I would like to take the square root of -3, I cannot take the square root of -3. So what I'm going to do is use the imaginary unit I to do this. So the I takes the place of the -1, which is basically just the negative sign in this. So the I will come out front and the 3 will stay underneath. Now remember, when I take the square root of a number, the answer can be both positive or negative, so you always want to include your plus or minus sign in front. So the square root of -3 would be equal to I square root 3, because the I just replaces the negative sign. Now if I have I square root 3 squared, then when I'm squaring this, this is like taking I square root 3 times I square root 3. Because when I square something, I'm just multiplying it by itself. So I times I would be equal to I squared. And the square root of 3 times the square root of 3 would be the square root of 9, which is just 3. So then that would be equal to 3I squared. But remember, we talked about I squared was equal to -1. So -1 times 3 would be equal to -3. So that would be the answer. And that should work because remember, I squared equals -1. So if I square root -3 times itself, then I should get -3. Alright, now we're going to talk about solving quadratic equations and getting imaginary numbers as answers. So if I wanted to solve 2x squared plus 11 equals -37, I would solve this like normal, so I would subtract 11 from both sides. And these would cancel out, and I would get 2x squared equals -48. So from there, I would divide by 2, and I would get x squared equals -24. And then if I wanted x by itself, I would have to do the square root of both sides to cancel out the square. And so I would get that x equals the square root of -24. Now I can't actually take the square root of -24, so I need to use the imaginary unit I. Now I can also break down the radical just like I did in the past. So what is the largest perfect square that goes into 24? Well, it would be -4 times 6, and we have the square root of all of that. So the square root of -4 would be 2i, because the square root of 4 is 2, and the negative part becomes the imaginary number I. So I would get 2i, and then square root 6. And remember, you always want to put your plus or minus sign in front, because the answer could be positive or negative when we take the square root. So this would be the solution to my equation. Alright. Now, a complex number in standard form, complex numbers have both a real and an imaginary part. So A is the real part of your answer, and BI is the imaginary part of your complex number. So you're going to have two parts, and you always want to notice that the imaginary part comes second when we're writing in standard form. So now we're going to learn about adding and subtracting complex numbers. So when we do this, we just combine like terms. This should be fairly easy for you guys because it's pretty much like what we've done in the past. So if we look at this example, they are asking us to add these numbers together. So I'm going to add the real parts and I'm going to add the imaginary parts. So 8 plus 5 would be 13, and negative I plus 4I would be positive 3I. And this would be the answer in standard form because my real part is first, my imaginary part is second. Let's try another one. So this time we are subtracting. Now I like to do keep, flip, change when I subtract because it's easier for me to add than it is subtract and get all those signs messed up. So I'm going to rewrite this as 7 minus 6I. And then I'm going to do keep, flip. So I'm going to flip this to positive and then change. And I'm going to change this to negative 3 plus 6I. Now you don't have to do that. You can do 7 minus 3, which is 4. Or 7 plus negative 3, which is also 4. You can also do negative 6 minus negative 6. So you'll notice that since it's minus and negative, it will turn plus. So those will cancel out. So if you did keep, flip, change like this, you'll notice negative 6 plus 6 is going to equal 0. So 4 is our answer. All right. Now this example, you'll notice that the minus sign is in front of the parentheses. That's like having a negative 1 there. So you need to change the signs of everything inside the parentheses. So it would be 10 minus 6 and then minus 7I plus 4I. So 10 minus 6 would be 4, and then negative 7I plus 4I would be negative 3I. So that would be the answer in standard form. So adding and subtracting is fairly simple. When we get into multiplying complex numbers, there are just a few more steps involved. So when I multiply, it's just like normal. Since I have parentheses, I would have to distribute the number on the outside. So 4I times negative 6 would be negative 24I, and 4I times I would be 4I squared. So I need to look and see if there's anything else that I can simplify. If you remember at the beginning of the lesson, we said that I squared was equal to a number. Do you remember what that was? I squared is equal to negative 1. So essentially, this is like taking negative 24I plus 4 times negative 1. So really this becomes a negative 4, and you remember when you write it in standard form, this part has to come first and the imaginary part has to come second. So we're going to end up with negative 4 minus 24I as our solution. Now when we have two binomials like this, how do we multiply binomials? Well, you might remember that we did double distribution. So you're going to distribute the 9 to both numbers, and then you're going to distribute the negative 2I to both numbers. So 9 times negative 4 would be negative 36. 9 times 7I would be positive 63I. Then I need to distribute the negative 2I. So negative 2I times negative 4 would be positive 8I. And negative 2I times 7I would be negative 14I squared. So if we combine like terms in the center, we'll get negative 36, and then 63 plus 8 would be positive 71I. And then we also remember that I squared is equal to negative 1. So negative 14 times negative 1 would be positive 14. And then I can combine that with the negative 36. So negative 36 plus 14 would equal negative 22 plus 71I. And remember, you want to keep this in standard form, so the imaginary part has to come second. Now, something that we haven't talked about yet is the conjugate of a number. The conjugate is like the opposite of an expression, so you change the sign in the middle. And that helps the imaginary parts of the number cancel out when we are double distributing. So the conjugate of 1 plus 3i would be 1 minus 3i. So all we're doing is changing that in the center, and that's important for the next part that we're going to talk about. So it says write the quotient 7 plus 5i over 1 minus 4i in standard form. So what that means is we have to have it as one number. Now, in order to do this, we want the bottom of our fraction to be a rational number. So we don't want any imaginary units in the bottom. So to do that, to cancel that out, you have to multiply by what's called the complex conjugate. So we need to look at our denominator, and we're going to multiply by the complex conjugate of 1 minus 4i. So I start with 7 plus 5i over 1 minus 4i. And in order to get my answer in standard form, I have to multiply by the complex conjugate, which is 1 plus 4i. And I need to do that to the top and the bottom of my fraction. So I can go ahead and put all of these in parentheses. So I needed to double distribute the top and the bottom. So if I double distribute the top, I'm going to take 7 times both numbers. So 7 times 1 would be 7. And then 7 times 4i would be 28i. Then I need to distribute the 5i. So 5i times 1 would be 5i. And 5i times 4i would be 20i squared. So that's what I get for the top. For the bottom, I'm going to double distribute. So I'm going to take 1 times both numbers. So 1 times 1 is 1. 1 times 4i is 4i. Then I take negative 4i times both numbers. So negative 4i times 1 would be negative 4i. And negative 4i times positive 4i would be negative 16i squared. From here, I need to just simplify. So remember, I can combine my like terms in the middle. So I would get 7 plus, and then 28 plus 5 would be 33i. And then I have 20i squared. And remember, I squared is equal to negative 1. And I'm going to do the same with the bottom. So if I combine like terms in the middle, 4i minus 4i cancels out. That's why we multiply by the complex conjugate, because that's what makes it cancel out. And then if I remember, I squared is negative 1, so I get 1 plus, and then negative 16 times negative 1. So if I simplify this now, this becomes negative 20, and 7 plus negative 20 would be negative 13 plus 33i. And on the bottom, this becomes positive 16 plus 1, which would be 17. So now I don't have any imaginary units in my denominator, which was the goal. Okay, then what I need to do is I have to, they're really picky about how you write this in standard form. They want us to separate this into two different fractions. So this will separate into negative 13 divided by 17 plus 33i over 17. So that's how it changes, so that we have a real part and an imaginary part separate, so that it's in standard form. All right. Now we can also plot complex numbers on a graph. Now the graph for this looks just like a normal graph, but there's a real axis and there's an imaginary axis. So the real value, the A part, is like the x coordinate, and the imaginary part, the B, is like the y coordinate. So this is actually pretty easy. It goes real, comma, imaginary. So if I'm going to plot these numbers in the complex plane, 3 minus 2i is equivalent to the point 3, negative 2, because this is the real part, this is the imaginary part. And this is the real axis, this is the imaginary axis. So it's just the same. So I would do 3, negative 2, and that would be equal to 3 minus 2i. So it's pretty simple. This one would be negative 2, 4, real and then imaginary. So negative 2, 1, 2, 3, 4. So this would be negative 2 plus 4i. And then 3i. Now this part we have to kind of think about a little bit. Remember, the real part comes first. There's no real number in this, so that would just be 0. And then the imaginary part would be 3. So this would be the point 0, 3. So that would represent 3i. So it's pretty simple. The last thing we have to talk about is how to find the absolute value of a complex number. Okay, now if we think about a graph, and we say that this is the complex plane, so we have the imaginary and the real, okay, the absolute value of a number is how far a number is away from 0. So if I want to find, like, let's say I had the number, let's just do this one right here, negative 4 plus 3i. That would be like graphing the point negative 4, 3. So I would go back 1, 2, 3, 4, 1, 2, 3. That would be right here. So this would be 4 spaces, and this would be 3 spaces. And if I wanted to find the absolute value, it would be the distance from 0, which would be this side. If you guys remember, that's like a right triangle. So to find the absolute value, we would do a squared plus b squared equals c squared. And so that's where this formula up here comes from. So if I want to find the absolute value of a complex number, I just take the square root of a squared plus b squared, because that's how I would find it over here. So a is the first number and b is the second number. So I would just take the square root of negative 4 squared plus 3 squared. So negative 4 squared would be 16. 3 squared would be 9. 16 plus 9 would be 25. And the square root of 25 would be 5. Now remember, because it's absolute value, the answer is always going to be positive, so we don't have both a positive and a negative answer. All right. Let's do one more, and then we'll be finished. So remember, we talked about this on the last one. Since there's no real value, a would be equal to 0, and b would be equal to negative 3. So to find the absolute value, I'm going to take the square root of a squared plus b squared. So I would get the square root of 0 plus 9, which would just be 9, which would equal 3. So that would be our answer. So make sure that you go back and read the essential question and write your summary.